Hey folks, let's get going. So I think I had sent out a note, and a couple of us were on the call last week about possible competitions. So at least I can tell you what my thoughts were, and then would like to hear comments. I think we discussed last week a little bit, and also I think since we haven't participated in any kind of time series competitions yet, we've done kind of segmentation, classification, and audio, and the last one was medical imaging. So at least my thinking is this, conveniently, there's this crypto something forecasting, which is more of a time series problem. One of the options that just came up, and it also gives us enough of a runway because it's all the way, I think the deadline is 1st of February of next year. So it gives us the full 2 months and whatever's left of this month, so about 2.5 months of runway. So at least that's my thinking. It's called, I think, the G-Research Crypto Forecasting Competition. But again, that's my thought, and some of the people who have been on the call and who have been actively participating in other competitions seem interested in that. That's at least my thought process right now. Would love to hear any other people's comments and thoughts.
Yeah, like I'd be quite keen to do the cryptocurrency one on Kaggle. Obviously with it being on Kaggle, it's easy enough to submit things to it. And yeah, so I've actually signed up for it already and just had a bit of a play about, but I haven't made any submissions yet. But yeah, like I think with it being a sort of a prediction thing, that there's like a load of different ways that you could tackle the problem or whatever. So it's pretty interesting from that point of view as well, in the fact that you could like try lots of different types of solution and then combine them.
Yeah, so yeah, I think time series is something that I've been wanting to try my hand at, and there's, as you say, there are, traditional machine learning like random forests and stuff that you can try. There's also more recently I've seen transformers applied to time series. I kind of wanted to see whether that would be applicable and stuff. So yeah, I mean, that makes it interesting.
Yeah, on Sunday I do it's the reinforcement learning course. So I've seen already there's a few people have been publishing notebooks with reinforcement learning approaches to tackling the problem as well.
Sorry, Yuri, you were going to say something?
Oh, I was going to say, I just signed up today for the other challenge for food security, just because it's basically, it's exactly the same problem I'm trying to solve at work, but with better data. So I'll be doing it anyway.
Okay.
Just because I had to get permission to do it, because it's too close. So, and I have to use different methods than what we're doing at work. So I'm interested in doing time series problem. Like my only hesitation with cryptocurrencies is that I don't know. It's a lot of times, like, it's interesting to do time series that are driven by some logical things. Like my impression is that cryptocurrencies are not like that. So like nobody knows what drives them. So it would be fun to work on the problem, but I don't know if it's you can actually get if there is a law, right? Like I don't know if there isn't a good answer.
Yeah, that may be true. I mean, who knows actually say to a large extent, it's also like stock trading, but I guess crypto has even less of reasons why things go up and down, and they have all kinds of different things driving it. But much like, in fact, what is interesting is even the last competition we participated in, the medical imaging competition, it turned out that after a lot of effort, in fact, the thing we learned, not just we, I mean, the competition organizers said as much, that what they learned is that even published papers on the data, which were claiming about 93% predictability, are suspect when the data that's used to evaluate the results is taken from a large data set that is not from the same lab or from the same set of data points that are used to train the data. So after a lot of work, the conclusion was that, we shouldn't be sure about what is happening. And in fact, even published results come into question, which, by the way, at least personally, I think that's a excellent result in some sense to come up with, because it otherwise tends to be kind of just a confirmation of the existing data bias. I mean, you're able to do a good prediction because you already have data which kind of represents that. But if you're trying to use it for medical purposes and stuff, and you really want to predict when you don't have similar looking data, then that result is very important to highlight. So as you say, it may very well be that, the applicability of it may be questionable, but then again, as Steve mentioned, and I'm kind of motivated by the same thing, there's a whole bunch of factors or a whole bunch of methods that at least I'd like to become more familiar with, that I haven't tried or even attempted in the tabular or time series space. So it'll be as much fun for that purpose as success in predicting. I mean, we did pretty poorly on the last competition overall too, but it was interesting as to what the challenges were and so on. Yep, so your point is valid, but I think reasons to do it aren't only as you say. I just, in fact, last week I was just reading something that I haven't fully gotten into, but application of transformers in a very different way to both time and space dimension, where they were trying to predict weather at two different locations and things like that, which may have underlying causes, right, rather than crypto. But hey, that's the problem we've got in front of us, so might as well try different techniques.
I think predicting crypto is actually pretty easy. Like, all you have to do is monitor Elon Musk's tweets or whatever, and you can do it. I've seen some people have actually created notebooks that are monitoring his tweets, but I think the trouble is when the competition actually starts running, you don't have internet access, so you can't actually do that when the competition's up and running.
But you can bring data sets though, right?
Data sets?
Well, you can bring it for trade. Yeah, you think you can use external data there, but you cannot use it. You can only use it for training. That's not available. Yeah. Okay, got it.
Yeah. So the trouble is that you're creating a model, and you can use whatever you want when you're training it, as you say. But yeah, once the competition's running and you're beyond the training stage, then it's what, 2 months is it that they're going to monitor for, or 3 months or whatever, to see who actually wins the competition. And like during that time, then you can't put any external data into your system anymore, I don't think. Although I saw on Kaggle as well that some people were using it's auto updating data sets or something. So I'm not sure, is it possible to get data into your model that way? I hadn't heard of them before.
So if we are getting into that one. Anybody else want to comment or add their inputs? If so, Steve, would you mind sharing what you were able to look at last week and stuff?
Yeah,
anything interesting, just EDA or?
Yeah, there's one guy who's been publishing like loads of notebooks. If I can find the ones that I was looking at. Yes, there was like another competition that was very similar to this about a year ago. It's called Jane Street Prediction. So
yeah, there was some stock market prediction type of thing, right?
Yeah, that's right. Yeah, so it was like similar to this in that you had to put your notebook in, and then the notebooks were evaluated over the next few months or whatever as the stock market actually went up and down. So yeah, like in that competition, there's sort of the notebooks from the winning entries from it and stuff. Let's see. Yeah. Can you see my screen there?
Yes.
Yeah, so this guy here, Jan Peleg, he's like published like a load of notebooks so far in this competition. And yeah, so I haven't submitted any of them, but yeah, so he's taken like this Jane Street one and made a notebook out of it. I think this one here was his as well. Oh, no, it's a different one. Yeah, so yeah, like obviously there's like LSTM versions, and then yeah, so this is like the this guy's one. It's like a reinforcement learning version of it. Yeah, so like within this, he goes into quite a bit of detail as well about how you actually sort of split the data up into like validation sets and things. Yeah, and he's made these these auto updating data sets already. So you can take his data sets that he's made, and yeah, like so he's some of the data is missing. I can't remember how long ago it starts or whatever. It's like something like 2018 or whatever the competition data is coming from. So he's gone back and he's added an extra year in, and then there's some of these cryptocurrencies that didn't exist then. So he's made sort of, and they're missing some data, so he's filled in the blanks as well. So, and his data as well, I think it's like updating daily or whatever, or weekly or something. So he's pulling in new data into his notebooks. So yeah, like he's done like.
I see. So it may very well be, I guess that would be interesting to see, meaning you potentially are just increasing the size of the data you use to train your model, but once the model is trained, then you don't care about that, right? That would be the usefulness of this auto updating.
Yeah, and it's the competition has like its own API or whatever. So like the API provides you data daily. So like once you've submitted your training notebook, you're going through their API, and it'll be giving you like the new data daily for you to make your predictions on. But I think his auto update data sets, I'm not entirely sure what extra they're adding into that. I need to look into it a bit more.
I have a question. Yeah. So we work with we're actually working with time series data and predicting something, and the way we're doing it, we're actually retraining the model every single day. So we get new data for every single week. So we get the data and we basically adjust parameters in their setup, would you be able to reach, like, let's say you get the new data for this day, would you be able to retrain your model using like past data and new data?
I think you can, yeah.
Okay.
Yeah, so I think you have like the two options or whatever. So it's you can obviously just like go with the model you have trained already, or if you sort of want to retrain every day, you probably can. I think there's obviously like sort of time limits on how long your notebook can run for.
I think, is it 9 hours?
Yeah, I
I don't
think
know
so.
if I was looking at. Okay.
Yeah, like that's what the normal is. So, yeah, so they have like this is the data set for like their whole training set. So like these are asset IDs. These are the different crypto coins or whatever. So I can't remember. I think it's like number 1 is Bitcoin and 2 is Ethereum or something like that. And yeah, so like this target value, like that's what you're trying to predict, which is I can't remember exactly
And
what it is, but
we are trying to predict for multitude of coins.
yeah, so there's 20 different coins, I think it is. Yeah, so these are, if you can see, yeah, so these are, so there's 14 of them. So like, I think that's what they're sort of saying is like, obviously like when Bitcoin changes in price, the chances are that all the rest of these cryptocurrencies are going to move as well. And so if you can sort of predict maybe how sort of the change in Bitcoin influences the change in the others, you could sort of predict their prices as well. And yeah, so the target thing, I think it's made up of something like the last 15 minutes or days or something. Obviously, yeah, like with it being a crypto coin, it trades 24 hours a day, 7 days a week. So it's not like a normal stock market. And then like you don't have sort of like an opening and a closing period on the stock market because it's going all the time. Yeah, so like this chart here, like it sort of shows the interrelationship between the things. So you can see here something like Bitcoin and whatever that is, Binance coin. They've like got a reasonably strong correlation. Whereas for whatever reason, Dogecoin doesn't seem to be related to anything. And yeah, so like this is the target formula, which is, yeah, so like that's the time period. I think it's 16 minutes or something. Like, yeah, over 15 minutes. So you've got to predict how the thing is moving in a very sort of short space of time. So like it just like takes the value 15 minutes in the future and divides it by the current time. And then each of the coins as well, it's got like some weighting which comes in a chart. So you multiply by the weighting. I think that there's like, it's sort of just like saying something like Bitcoin is more valuable than some of these other ones. Yeah, so like one of the CSV files that's provided with the competition gives the weighting with it. I can't remember which file it is, but.
So you're saying that the predictability of the more importantly weighted coins matters more? Is that the takeaway?
I think so, yeah. So yeah, like I think something like Dogecoin or whatever, it's considered to be not that sort of important to their thing. I think they're sort of saying that Bitcoin's worth the most. I can't remember, sorry, where the weighting table is. I can't find it at the minute, but yeah, so like each of them's.
Yeah, that's fascinating because just last week, and I'll see whether I can dig up, there was this paper we talked about using transformers to do time and space. And by space, they meant that, in the, at least quick takeaway I had from skimming the paper is they were talking about in transformers, one of the things when transformers are applied to words is all the different attributes of the word. A word is a single embedding, right? So every whatever nuance, every bit represents the same thing with respect to the word. But what they were trying to do was, if you have something like this, where you have a multitude of coins and time steps, then they were trying to flatten it so that you would have, let's say, 5 coins and 5 time steps. Then you would have 25 sequence instead of thinking of it in a transformer applicability towards context of just 5. Right. So because here you're individually wanting to predict each of the 5 coin values for the 5 steps. And I thought that was an interesting approach, and they showed that their performance was better compared to other techniques. So if I can dig that paper up, then I wanted to kind of dive into it more from the standpoint of, if we choose this computation, then it would seem to be very relevant, and they seem to be, it's a recently published paper, I think. So
Yeah.
try and dig it up at post.
Yeah, so this guy, Jan Peleg, he's done a transformer model as well. He seems to have done about 20 notebooks already for this competition, all different ones or whatever. So he's been busy. Yeah, like he's done all of these notebooks, I think. So yeah, he's got a transformer one if you wanted to look at that. I haven't looked at it, but you could maybe put your stuff from your paper into that.
Yeah. Cool. Yeah, so it seems there's a lot of different approaches.
Yeah, I think, yeah, like I was just sort of skimming through them and stuff, and yeah, like there was a summary of the Jane Street competition. I think a lot of people who finished well in it, they were using XGBoost, but I don't know anything about it really.
Yeah, that's another technique that, if you recall, Mehul was talking about using that technique for our previous competition as well. And that's like, and we kind of touched on it in the hands-on machine learning course that we went through, one of the study groups. And again, as I try to recall it, the basic approach was it's gradient boosting, which is, each time you try to find the difference between your prediction and the ground truth, and try to boost the signal to be able to get better at predicting the delta. Right. So each subsequent attempt is, and again, I could be totally wrong in mixing up things, but that's where the gradient boosting comes from. That is the difference between your prediction and the ground truth. You take that and you try to get closer. So each time you're kind of focused on the difference or the delta and trying to reduce it.
Right. I remember like doing them before, but I can't remember. I need to go back and visit them.
Yeah, exactly. Same here. You have to go back and refresh the principles or how exactly you apply it in different cases. But seems like there's, a plethora of techniques that you could attempt, and if I'm totally unfamiliar or I'm just remotely familiar with RL, and it's kind of fascinating that's finding applicability here as well. So, Yuri, to your question, yeah, I was just looking at it earlier in the week, so I'll dig up. I believe I have it saved, or at least I know where to go find it, and once I do, I'll post it on Slack. But they benchmarked it against prior approaches, and I just thought it was fascinating approach, and if we choose this, that I wanted to definitely try it, given they have compared their approach to multiple existing methods and said they perform better. So I'll post that on Slack as soon as we are done, and I have a few minutes dig back through what I've been going through. They also have at least what I read said they have GitHub posts about using their methodology. So the code is all available, so that ought to make it somewhat simpler to use. Okay, anybody else want to share anything else? If not, I think given we just have started, I would encourage people to kind of go through the EDA, much like Steve has already attempted to do, and share any kind of thoughts or different approaches that they would like to try, or even just EDA exploratory data, what they found, what kind of things, and share what they are wanting to try for this competition. Anything else anybody wants to comment or chime in? If not, thanks for joining everybody. Today is a quick one since the main purpose was to decide on which competition we'll go after, and hopefully we'll each spend some time on our own on the crypto prediction challenge and have something to share next week. Thanks, everybody.
Okay,
See you all
thanks.
next week.
Speak to you later. Bye.